This is a free response question that is very similar to what I expect the 2020 free response questions to look like. This is not an official AP question. This is just something that somebody out there created and was nice enough to share with the world on Facebook. So here we are. We have a table of values of a function that is twice differentiable. That's pretty important. F double prime is greater than 0, which tells you that this function is always concave up. So f is concave up. Selected values of f prime are provided, and we have some initial condition, f of 7 being 4. I don't know if it helps you to write that as an ordered pair, whatever. Okay, so approximate f double prime of 1. And then is there a time that f prime equals that approximation? So I'm looking where x equals, that's -1. I'm looking for x equals -1 on the table, and that would be between -2 and -2 and 0. So what we will do is approximate f double prime and -1 by finding the slope between those 2 points. And in problems like this, on the actual AP exam, they will typically write something like show the computations that lead to your answer or something like that, or they have in the past. And so what you need to do in order to get full credit on this one is you must write what's called the difference quotient. You cannot simply find the slope in your head and write the fraction. You must actually write your change in y, -2 minus -8, over a change in x, which is 0 minus -2. And then we can do the arithmetic to clean it up if you desire. I typically don't. Usually I'll stop right there. However, then the question goes on, is there a time c on the whole interval, -2 to 7, where f prime is equal to this approximation? So to answer that question, I have to have some number that I can wrap my head around. So I'm going to simplify this. That's -2 plus 8 is 6 over 2, and we get a value of 3. And so now, is there a time that f prime of c is equal to 3? That's my question now. And usually, if I see a question that says, does f prime of c equal 3, I think about the mean value theorem, because the mean value theorem says that if a function is differentiable, which this one is, this is twice differentiable, then there must be a point where the derivative at a point is equal to f of b minus f of a over b minus a. That's typically my first thought. That's not going to work this time because we don't know what f is. We only have f of 7. We do have a table of values for f prime, and because f is twice differentiable, that means that my function, that my derivative is continuous, and we will use the intermediate value theorem on this one. So that was just kind of a thought, a fleeting thought that I abandoned. Let's see, so f prime is continuous on the whole interval, -2 to 7. And I am looking for a place where f prime could be 3. And I noticed that from x equals 2 to x equals 3, my f prime goes from 2 to 6. We have to cross 3 somewhere on that interval by the intermediate value theorem. So then I'll continue. F prime is continuous on -2 to 7. F prime of 2 is equal to 2. And I like to focus on the value we are trying to achieve. That 2 is less than 3. And f prime of 3 is equal to 6, which is greater than 3. Therefore, f prime of x equals 3. And I'm not going to say f prime of x. I'm going to say f prime of c, because that's what they asked. Although f prime of x, you wouldn't lose points for that. I'm just being a little bit mathy here. F prime of c equals 3 somewhere. That's a really horribly written somewhere on the interval 2 to 3. And that's usually the way I first approach an intermediate value theorem, is I kind of narrow it down to a very small window. However, as I was writing this, I realized that I could have just gone on the whole interval, -2 to 7, because f prime of -2 is -8. That is less than 3. F prime of 7 is 11. That is greater than 3. And so we could have actually gone from -2 to 7 the whole time, which may have been a better idea since that was the interval they specified. Not really a big deal. Okay, B, evaluate that integral. Now notice they did not say approximate, they said evaluate. And to evaluate a definite integral, you've got to do the antiderivative of whatever the integrand is. They say show the work that leads to your answer. I don't know how you could possibly do that without showing any work. You couldn't possibly do that in the calculator. This one, I am looking at this and I see the antiderivative of f double prime, and I'm going to kind of, for a moment, ignore all the garbly poo on the inside, but the antiderivative of f double prime would be f prime. So what I want to try to do is simplify this to get rid of all that junk, and that would be accomplished through u substitution. I'm going to let u equal the inside, x squared minus 2. du is going to be 2x dx. And so I want to create a 2x dx. I have a 5x dx. That 5 is in the way. It is not helping me. So I'm actually going to take that 5, move it out here, and I'm going to rewrite my integral as 5 antiderivative of x f double prime x squared minus 2 dx. And now to create my du situation, I'm going to put a 2 in front of my x and a 1/2 out here. And this integral will then turn into 5/2 antiderivative of the 2x dx is my du. So I replace my du first. I always like to do my du first. And then I'm left with f double prime of u. And now my integral is exactly what I was thinking earlier, only it's a u instead of an x. No big deal. That antiderivative will be f prime of u. And I realized I ignored my limits of integration. So let me go back and put those in. This is from 0 to 3. And I'm a huge fan of converting limits of integration. These limits of integration, 0 and 3, are values of x. So if x is equal to 0, then u would equal 0 squared minus 2, which is negative 2. And if x equals 3, then u is going to equal 3 squared minus 2, which is 7. And now I can finish the problem without having to go back to x's. And so the antiderivative of f double prime of u would be f prime of u from negative 2 to 7. That would be f prime of 7 minus f prime of negative 2. Don't forget that there's a 5/2 hanging out in front over here. And then we go up to the table, and those values of f prime are 11 and negative 8. So the final answer is 5/2 of 11 minus negative 8. Absolutely no point in cleaning that up, so I will not. I'm going to leave it like that. So let's move on to part C. So we have function g being introduced, and g is given by f prime of that mess. Find critical values of g. So critical values, first thing I'm going to think is that I need g prime to equal 0, and then classify each as a local min-max or neither. Justify your answer. So you always want to make sure you have work that supports your answers. So g prime is going to be a quotient, a chain rule. So that would be f double prime of 2x squared minus 9x squared. That's 2x cubed minus 9x squared. Then we have to multiply by the derivative of the inside, which would be 6x squared minus 18x. That needs to equal 0. And so now we're going to do some algebra. I'm going to go ahead and pull this f double prime out. F double prime of 2x cubed minus 9x squared does need to equal 0. Every single factor needs to equal 0. And so we will set that equal to 0 and figure out if there's a way to come to any conclusions on that, because our table is actually for f prime. Then we need to set this equal to 0, so we'll factor out a 6x. That'll leave x minus 3 equals 0. The easy solutions, x equals 0 and 3. And then the more difficult ones here, f double prime, we need to find out when f double prime is equal to 0. But if you go back and read the problem, and I made note of this a while ago, they tell you f double prime is always positive. Now, we made the conclusion that that meant that f is always concave up. In this case, it means that there's going to be no solution. F double prime will never equal 0 because it is always positive. And so now we need to determine which of the critical numbers, 0 and 3, are maxes, mins, or neither. And so we're going to organize that on a number line, and keep in mind that the number line is absolutely 100% invisible to AP readers. They will not look at a number line for any type of justification or supporting work. So this will justify your answer requirement must be done independent of the number line. It's just a nice little organizational tool. I like to label my number line. This number line does represent the derivative of G. 0 and 3 actually make G prime equals 0. And then we're going to pick our test points. I'll do -1, I'll do +1, and +4. And we're going to determine if G prime is positive, negative at those values. So G prime of -1 would be F double prime of -1. And F double prime is always positive, so I'm really not worried about that one. And then 6 times -1 squared is 6. -18 times -1 is +18. That will give me a positive result. And what I wrote right here, this piece, absolutely must be written. Then we're going to test G prime of 1. Again, the second derivative is always positive, so I don't need to worry about that one. 6 times 1 minus 18 times 1 is -12. That will result in a negative. And then G prime of 4. Second derivative is always positive. 6 times 4 squared, 6 times 16 minus 8 times 4. You know what I'm going to do? I'm going to actually plug in right here. This will make the arithmetic a little bit easier because 6x times x minus 3 is the same thing as 6x squared minus 18x. And so 6 times 4 is 24. 4 minus 3 is 1. And now I can look at that very easily and tell that that's going to be positive. Okay, and then classify each as a local min, max, or neither. And we have one of each. And when you are justifying those, because we have first derivative information, we will say that there is a maximum at x equals 0 because f prime changes from positive to negative. And I like to restate the value, even though it's a little bit redundant, at x equals 0. Move this out of the way. As a matter of fact, I'll probably have to take that to the next page. I'll just cut that, paste it, cut. All right. And then we have a local minimum at 3 because f prime changes from negative to positive. And then I'm going to make a point about your supporting work. I made the claim, my justifying statement was that f prime changed from positive to negative and negative to positive. If you're going to make those claims, you must support those claims with written work. So here is what my justification was. F prime changes from negative to positive and positive to negative. This right here is the work that supports those claims. I found the test points and I determined that they were positive or negative. And this written language right here is endorsed by College Board, it is accepted across math, and everybody knows exactly what that means. The number line has never been standardized in the world of academia. And so they will not look at the number line. The number line is invisible. So if you want to, when you finish a problem in which you use the number line to support your work or to find an answer, when you're done, cover it up and see if your answer still makes sense by itself with everything else. And if it still makes sense, if you still have supporting work, then you are good to go. But do not count on the number line to support any of your statements in your free response questions. All right, so I now need to paste that part that I cut. We're going to do part D. This is a Riemann sum question. And so let's see, copy over paste. Let's see how this one works out. So we're doing a left Riemann sum with 4 intervals indicated by the table to estimate f of 0 Okay, and we have f of 7, and they gave me f prime. All right, so I'm going to go a left Riemann sum. So f of 0, okay, what I'm going to do, because I have f prime and I have an initial condition, f of 0 is going to be f of 7 plus the integral from 7 to 0, and it is okay to go from right to left, of f prime of x, and that is your net change theorem. And the Riemann sum is going to approximate this guy. Now, the Riemann sum, it is an approximation, so I'm going to put an approximation symbol there. F of 7 is 4 plus, and here is where I do the Riemann sum. And my area here, what you have to be careful with is that we are going from right to left. So from 7 to 4 is a change in x of -3. 4 to 3, I went down 1. 3 to 2, I went down 1. 2 to 0, I went down 2, because we are going from right to left. So we're going from here to there. And those are negative changes. So watch out for that. And then we'll do the area of the rectangles. Just make sure you are using the left endpoint for each interval. And so my first rectangle has a base of -3, and the height is the function value at the left endpoint. That negative looks stupid. And then I will add to that a change in x of -1 and a height of 6. Add to that a change in x of -1 and a height of 2. Add to that a change in x of -2. Oh, why did I do that? Oh gosh. Or was I -1, height of 2? Is that right? Yeah. And then a change in x of -2 and a height of -2. And I'm not going to clean that up. They don't ask you to interpret that. I don't need to use that. I don't think I'm going to need to use that answer later. They do ask if this is an overestimate or an underestimate. And the way we'll figure that out with a left or right Riemann sum is determined by whether the function under which you're finding the area is increasing or decreasing. All right, so here's where the concave up part helps you, and you have to be careful, because this, in the back of my mind, I was kind of confused about this a few seconds ago. We found the area under f prime. And so I need to determine, is f prime increasing or decreasing? And if f double prime is positive, that is the derivative of f prime. That means that f prime is increasing. The relationship from f prime to f double prime is the same relationship as f to f prime. And so f double prime positive, f prime is increasing. And if you have an increasing function and you estimate area with left Riemann sums, your rectangles will always be underneath the curve. So this is going to be an underestimate. And the reason for that is that f prime is increasing. And so I would say it's an underestimate. Because, and I'm going to go and tie that back to f double prime being positive. F double prime is positive, therefore f prime of x is increasing. And that is good enough. They're looking for a connection to the fact that the function under which you found area or estimated area is increasing. So finally, that brings us to part E, and this is a differential equation question. We have dy dx is all this mess. Initial condition h of 2. So h is the solution. So we have an initial condition h of 2 is -1. Sketch a slope field for that differential equation, and then use the tangent line at h at 2 to approximate 2.1. So two separate problems. I don't think they are going to be related. We have how many points? 9 points, and they always indicate the number of points because some of them that are on the axis are a little bit hard to identify. So they always tell you how many to look for. Okay, so let's start doing this. So my slope at 0, 1, and you don't have to show the work that leads to your slopes, but it may not be a bad idea. So if I plug in 0 and 1, I would have 1 times f prime of 0, which is -2, over, so this is for the point 0, 1, over 2 times 0 minus 1. And that's going to give me a slope of 1. So I'm going to sketch a quick slope of 1. And then if I plug in 0, 0, I would have 0 on top. F prime of 0 is negative 2 over 2 times negative 1. So 0 over negative 2 is 0. Plug in negative 1. So this is ordered pair 0, negative 1. So we have negative 1 times f prime of 0, which is negative 2, over 2 times negative 1. So that's going to give me a slope of negative 1. Then we're going to go over here and repeat. So we have the ordered pair 2, 1. So 2, 1 gives me the slope of 1 times f prime of 2, which is 2, over 2 times 2 minus 1. That's 2 over 2. That's another slope of 1. Plug in 2, 0. So 2, 0, y be 0 on top, 2 times 2 minus 1, and so we have another slope of 0. And then at 2, negative 1, negative 1, f prime of 2 is 2, over 2 times negative 1 minus 1 is negative 2. Something a little bit different. That's negative 2 over negative 4. That's going to be a slope of 1/2. Is that right? I just wasn't expecting it to be negative, or positive, I mean. Let's double check that. So negative 1, f prime of 2 is negative 2. Yeah. Oh, no, it's not. Okay. Stupid. Okay, so my denominator is 2 times x minus 1. My x coordinate is 2. So 2 times 2 minus 1 will be 1. So that's negative 2 over 2 is negative 1. Okay. I was expecting something negative. Usually they kind of follow the same trends. I saw a negative here. I was expecting these to continue to be negative on the bottom. And on top, I expect those to continue to be positive. Let's see if it does that. So if I plug in 3, 1. So if I plug in 3, 1, so my y coordinate is 1, f prime of 3 is 6, over 2 times 3 minus 1 is 2, so that's 6 over 4 is 3/2. Now that's going to be tough to get exact. However, 3/2 is greater than 1, which is what I have here. So what they look for on the AP exam is just for something that's steeper than what you had in that previous spot. That was a lot steeper. So something that's a little bit steeper. If I plug in the ordered pair 3, 0. If y is 0, my numerator is going to be 0. And my denominator, the reason I'm going to plug it into my denominator, I want to make sure it's not another 0 as well. But I don't think it will be, and this one won't be. It's going to be 2 times 0 minus 1. No, 2 times 3 minus 1, which is 2. So we get another 0 here. And then finally, plug in the ordered pair 3, negative 1. If you plug in 3, negative 1, we have a y coordinate negative 1. F prime of 3 is 6, over 2 times 3 minus 1 is 2. And that's going to be negative 3/2. And so that's going to, again, be steeper than the slope of negative 1s that are to the left. And so make something a little bit steeper. And there's your slope field. I spent a lot more time on that slope field than I thought I would. But there we go. I'm going to shrink these up, just try to get them out of the way. And then the equation of a tangent line. This should be an easy question. The problem you will have to deal with on the AP exam is a lot of times they put easy questions towards the end and you're brain fried and you're mentally fatigued and you don't want to think. However, this should be easy points. The tangent line, you always need a point and a slope. The point was explicitly given to you for h, that is 2, negative 1. The slope is almost always found by plugging your point into the derivative. There are some exceptions to that. Boy, the sun's coming up and I'm getting washed out here. All right. And so my slope, this one's no different. I'm going to plug my ordered pair 2, negative 1 into the derivative. So that's going to be dy dx at the point 2, negative 1. And that would lead to negative 1 f prime of 2. Hey, do you know what? I don't have to do all that because I've already plugged 2, negative 1 into my derivative to get that slope, and that slope was negative 1. So I'm going to bring that up here, and my slope is actually going to be negative 1. And so now I can write the equation of my tangent line, y minus a -1 is equal to my slope of -1, x minus 2. And I'm going to move that 1 over. I typically don't. However, in this question, they ask you to approximate h of 2.1. And so now to get h of 2.1, we're going to plug 2.1 into that tangent. And I'm going to stop there. There's no need to clean that up. You don't do anything with that answer. We are down to arithmetic and we would stop. So that is all of this question.